Hello everyone, I am Conrad Leray from the HPC Field Engineering team at ARM. Thanks for joining us today for this talk about EasyBuild on ARM. EasyBuild is a well-known tool in the HPC community for managing scientific software in an efficient way. And as the ARM architecture makes inroads into the HPC sphere, one may wonder what challenges they will encounter. Today, we are going to explain how EasyBuild can help in the transition. Our guest speaker today, Terje Kvernes, he is the head system administrator at the Department of Mathematics at the University of Oslo in Norway. Terje, we are very pleased to have you with us today. Please tell us more about EasyBuild on ARM.
Thank you, and welcome to this SC'20 talk on the topic of running EasyBuild on the ARM platform. My name is Terje Kvernes, and I am the head sysadmin at the Department of Mathematics at University of Oslo in Norway. And about 5 years ago, we at the department started to offer a limited set of HPC software for our staff and students. Not knowing any better at the time, I started building a lot of this by hand, which was not fun. So I started creating wrappers for the builds, which was a different kind of not fun. Then machine learning came along, and our users requested TensorFlow and PyTorch. At this point, the wrapper scripts had become unwieldy. But then I got lucky. I found EasyBuild, and I so dearly wish I had done so sooner. The picture you see of me there is me staring out over a lake, thinking, dear God, do I have to build EasyBuild again? Thankfully, I don't. Now, a brief primer on EasyBuild. It is a build and installation framework for scientific software. It allows for reproducible builds with full dependency tracking, while supporting multiple versions of the same software to be chosen and loaded on demand. There are 16 core maintainers and well over 100 unique contributors at this time. And the other half of the puzzle, ARM. Now, Linux works on ARM, so things should just work, right? Well, HPC software is written by researchers with limited development experience. And add to that the compiler options and optimizations that often go into HPC software, and things can get quite messy. So the software doesn't always just work, so EasyBuild maintainers had to produce some patches to make this actually work. This is fine, but it's not sustainable in the long term for EasyBuild developers to sit on these patches forever. But there are good news. And these good news are that the core system works fine. ARM is well supported on Linux. You get kernel drivers for InfiniBand, network, and so on that work without a problem. Languages, or development languages, work fine. GCC, Perl, Python, sure, not a problem. Except a number of GCC options that are often used, like mno-recip and miefp, simply don't exist for ARM. So what do? Well, EasyBuild takes care of that by seeing these options and going, no, I know you asked for that, but we're going to give you something that works on the platform you're on. And then we see platform tests, which happen more often than you'd think. And one of the things we came across a fair bit was situations where somebody asked, is this a 64-bit platform? Unfortunately, the way they tested that was to see if the platform was x86-64, which works in a somewhat limited fashion. Then you see dependency on x86-64 unique software, like YASM. Okay, again, EasyBuild will allow you the option of saying, filter out this dependency, and you can continue on your work. The more tricky bits are the pieces of code where you encounter inline assembly or SSE intrinsics. This is often very smart. I mean, it's very performant when done right, but it isn't very portable. Thankfully, there are some solutions for this. most things are easily fixable. They require a define or two, and that's it. Now, EasyBuild takes care of some of those compiler goriness and a few of the other details that you otherwise had to think about, but you end up with a list of kind of tricky things that linger in the background. Things like the SC' intrinsics. There are ways of getting around that with libraries such as SC' Neon, but they are not well used from the environment yet. Some examples of our experiences with this. Mesa is a 3D graphics library, and it works really well out of the box. But there were some small issues when you have the option of building it with lib unwind, and for some reason that didn't work for us. Again, like with Yasm, EasyBuild was told to filter it out, and we could go on with our day. R has similar type of issues. There are some small niggling 64-bit tests and such that didn't work as expected for people, but thankfully we have long experience of porting this to Power, so we just took the same Power patches and applied them to ARM, and things worked fine. OpenFOAM, well, they showed us that you should never underestimate what you can actually encounter for problems. They simply had chosen different versions of OpenFOAM, had chosen different versions of ARM, or different capitalization, which led to things like sanity checks and similar just dying. That got fixed, so okay. But again, it's the kind of thing where EasyBuild learns this and it goes into a long-term solution. Now, as for long-term solutions, Bioconductor provides tools for the analysis and comprehension of high-throughput genomic data. It is built on top of R. So once we got R to work, the next question was, will Bioconductor work? Well, no. A number of the modules we came into contact with there used SC' intrinsics, and they used them directly without using any support libraries like SC' Neon or similar. They had hard-coded platform support without any fallbacks for anything generic. And in one situation, they used code that only ran on one specific platform when using GCC. That was a bit of a surprise. However, there was no surprise on which platform it actually worked on. So we sent the patches upstream. Good. And then what? Well, the responses are sometimes positive, and that's cool. That's very nice. It's very nice to see that things just work, but sometimes we get responses along the lines of, I don't accept patches I can't test. And that makes perfect sense. It's not great fun to take in things that you have no idea whether or not actually are good. It's more annoying when you get the responses of, we don't support that architecture or that platform, this configuration or something similar. You're left wondering why, but there's not much you can do about it apart from trying to be polite about it. And of course, in one situation, like I mentioned with the GCC code that only worked on one platform, the response was also, we have coding standards, so that's why it looks like that. So your patch that fixes it so it works on all platforms is a violation of a coding standard. But your coding standard doesn't allow it to work on right. Not the most fun conversation you'll have, but they do beat the conversations that are essentially go away. Why are you applying patches to our code, or why do you even care? And yeah. And then of course, the last option is absolute radio silence. You submit the patch and then nothing happens forever. After working with this for getting a lot of the EasyBuild stack onto ARM, that picture in the background there are salmon going upstream. And yes, I'm aware that for most of that salmon, that is not a thing that ends well. It's a one-way trip of sadness. After working with deploying patches upstream for a while, I do empathize with their experience. In the meantime, thankfully, EasyBuild will keep the patches and pave over the cracks and make sure that things still work. So why? why does this happen? Well, for one thing, knowledge. A lot of the developers simply don't know any better. It's just that simple. And when they know better, some of them will say, well, I can't test on that platform on ARM, so what am I supposed to do? And even if I, take in your patch and I say, okay, I will take it for granted that you have done this testing and that it works, how do you prevent that patch from just rotting because there are no more tests to be done on it? Maybe the person who submits the patch just leaves for greener pastures, and the person's trying to maintain the code now have a patch that they don't know how to test. In 3 versions onwards, does the patch still actually work? Maybe, maybe not. And then there's the problem of experience or simply lack of familiarity. People are used to x86 64, and that's that. And interesting enough, we came across something which is a bit of a surprise, and that is a lack of hubris from researchers and software developers. Not normally a problem, but sometimes they will simply state, well, this is just going to run on our machine or my machine on my desk or my laptop, so we don't really care. Well, unfortunately, other people do, so yeah, but oh well. So then, how do we improve the situation? Well, outreach, just to get the name out there, getting ARM familiar to people will definitely help, and Apple will certainly make that happen as they start shipping ARM into their MacBooks. Tooling will help, using EasyBuild, or either directly or indirectly by supporting EasyBuild, will help in making sure that software works on ARM. And of course, the developer guide from ARM is fantastic. If you ever wonder how to make things work, not just on ARM, but in general, it is a fantastic guide. Highly recommended. And as for the testing bit, well, AWS offers Graviton 2, which is fast, relatively cheap, and very available. And if that isn't an option, Singularity offers the free use of remote building for different architectures than what you're sitting on. Unfortunately, we've had some trouble getting that to work properly, but it's definitely getting there. And then, of course, there's always the option of a Raspberry Pi. 64-bit, runs ARM, it's fine. Now, in closing, I would like to say a few words about the European Environment for Scientific Software Installations, EASY. We talked about making things work on ARM, but imagine one software stack for all your architectures, optimized for your microarchitecture, available on demand from anywhere, for your laptop, for your desktop, or for your supercomputing cluster. This may very well sound like magic, but it isn't. It is easy. I wholeheartedly recommend you take a look at it. Thank you for your time.